What's up? What's up? What's up? It's your boy, the network. And today's topic is section 3.13, identify suboptimal routing. This is a topic in the CCNP route exam code 300-101 version 2.0. Hashtag lab every day. Even though we haven't been labbing every day, like I said, life happens and sometimes you just gotta make it happen, Let's go ahead and take a look at the exam blueprint to see where we came from and where we are headed. Okay, this is the exam blueprint implementing Cisco IP routing, also known as the CCNP route exam. This is exam code 300-101. We wrapped up a couple days ago. It's been a minute since I've done a video. Like I said, life happens. I got a kid, I got a girlfriend, I got a job. Life happens. So we just gonna make it work though. We wrapped up configuring and verifying policy-based routing, also known as PBR. Today we're going to be identifying. Notice it says identify. That's the key word here. We don't really have to, there's nothing really configure. There is something that you can do to kind of fix this problem, but notice it says identify. So we just got to know what suboptimal routing is. It is good if you want to go further into it, learning how to, that's what we're going to do. We're going to do a little bit of how to resolve this issue. After that, we're going to move on to explaining route maps. Like I said, I did not really like the sequencing of this exam because route maps should have been covered before policy-based routing. That's a part of it. It should have been before filtering routes and stuff like that. That should have been up there, but whatever. Like I said, there must be a reason why they did that. Anyways, we are going to identify suboptimal routing. What is suboptimal routing? When you think about the word sub, when I first seen it, I was like, oh, okay, that sounds like it's a feature or something. No, no, it's not. When you think of suboptimal, think of the word subpar, which is meaning like below average, below something we don't really want. It's not as the word optimal means, good or efficient. Suboptimal routing is a problem. Now, let's go ahead and take a look at the slides real quick so I can show y'all, not the official definition, but I just want to give y'all an example before we move on to that. Okay, so y'all know how I like to compare networking to roads and highways, right? Let's take you got this map of the United States right here, right? Let's say, y'all know my favorite city. I have never yet to visit there yet, but I'm going to one day. Los Angeles. Let's say we are in Los Angeles right here, right? And we're trying to get to Phoenix, which is right here. It's not that far. It's probably, I believe, maybe a 4-hour drive. I haven't really Googled it, but Phoenix is right here. LA is right here. Obviously, we could just take a direct route to Phoenix and make it there, right? That's real quick. Let's say for whatever reason, your GPS ain't working, or you got your significant other that could be an airhead sometimes, and they give you some totally out of whack directions and got you going to Phoenix from LA, going northbound past San Francisco, Sacramento, Carson City, Salem, Oregon, Helena. They made you do all this just to make it to Phoenix. That circle route that you took to all those states just to make it to Phoenix will be considered your suboptimal route. It was not very efficient, obviously. It probably took us, days to make it from all them states just to make it to Phoenix, when we could have just went from LA directly to Phoenix like that, which is probably a 5-hour drive. I don't know. Official definition. Suboptimal routing occurs when there are multiple points of redistribution between the same two routing domains. This happens because administrative distance is used to determine best route, and when routing domains have different ADs, that a router may think a redistributed route is better than routing directly into the connected route. So back to these, before we get to the routers and switches, let's head it back to this. I forgot to say, let's say the reason why, not because you have an airheaded wife or whatever, or your GPS ain't working. Let's say you found a toll road that was a lot cheaper to go this way instead of taking the really expensive toll road to go this way, but it would have gotten you there quicker, right? That's the reason why you took the longer route, because you figured, oh, this route is cheaper, let's go that way. But you didn't really realize that it is the longer way. So, and when you're doing redistribution, that causes that problem with suboptimal routing. It looks at, remember, routing protocols uses administrative distance to figure out the best route. And the lower the administrative distance is, the better the router think it is. But however, we can manipulate that. That's actually one of the solutions to fixing suboptimal routing. So yeah, again, I forgot to make that point. when I was talking about the maps. Now, so back to these routers right here. You look at this example right here. We're going to do an example in GNS3 that's very similar to this route right here. As you can see, we've got router 1 and 2. They're going to be redistribution points. And that's one of the problems with when you have multiple points of redistribution. Router 2 is in both a RIP domain and our OSPF domain. Router 1 and 2 are both in those domains, right? So he's a redistributing RIP route and he's a redistributing OSPF route, vice versa. So let's go ahead and take a look at that. Router 3, let's look at the vantage point of router 1, right? Let's say router 1 is trying to get to router 3, right? Router 3 has, as you can see, has a, if y'all are fast reader, y'all could get through this before I explain it. Router 3 has a RIP route for 3.3.3, right? That's basically his loopback address. Router 1 knows of this route via RIP with an AD of 120, right? That's actually the default AD for RIP routes, right? Router 2 also knows of this route that's located on here from the OSPF domain. It was injected into him. It will use that route due to the lower AD, 110 from OSPF, which is better than 120, right? So traffic R1, which is router 1 right here, that he forwards to 3.3.3 will be sent into OSPF domain that way per router 1's routing table. So when he looks at his routing table, he's going to say, oh, to get to router 3, I have an OSPF route. That's 110 instead of going this way, which is 120. So he's going to go to get to router 3. He's going to go all the way to router 4, router 2 to get to router 3 when he could have just went directly that way. But the reason why he went that way was because it's an OSPF route, and the OSPF by default, the AD, the administrative distance, is 110. So he's going to go that way instead of this way because this was 120. So he didn't want to go that way. But he could have went that way. Duh.
I don't think so. Homie, don't play that.
Router 1 could have just went that way. So this would be, like I said, this is just like the United States. If you taking all them other states, instead of going directly to router 3, he went to router 4, router 2, then to router 3. That will be considered a suboptimal route. That is a problem. This can cause problem. This, obviously the traffic got there, but it is a problem because it just took the long way to get there. Here's one more example. I'm not going to get too much into the configuration or whatever, the loopbacks or whatever, but I just like this one because I found this one on the internet. By the way, a lot of this stuff I've been finding on the internet. If it's yours, I just got tired of sourcing this stuff. I just been grabbing this stuff on there. If you see it, just put a comment below if it's yours, and I'll give you credit for it. But if you just do a quick Google search, you'll see this on there. But I just like this one. This is a perfect example. It has arrows and everything on it. Let's say router 2 is trying to get to router 7, right? Obviously, he could have just went to router 6 to router 7 and made it there, right? But he learned about this way through you can redistribute connected routes as well. Router 6 redistributed connected route. A redistributed connected route will give you an AD of 170. You would think he would have went that way because it was 190, but no. He is in the EIGRP domain, but he learned about the 170. He learned about this route through a connected redistributed route, which gives him 170. But instead, he like, oh no, this way is better because the administrative distance is 110. So he decides to go this way to router 3, to router 1, to router 4, and then to router 7. Obviously, that was a longer way. He could have just went directly to router 6, straight to router 7, but instead he took this red route. That should have gave him a clue that he was walking down a red route. That's not a red carpet. He should have took the other way. So that's obviously a suboptimal route. What are the solutions to this problem? Obviously, hire a network engineer that knows about suboptimal routing and redistributing correct routes. Or you can change the administrative distance, AD, of redistributed routes. Remember, we can manually do this by just typing distance, and then you can modify it from there. Once you change, and remember, the lower the administrative distance, the better, not the higher. So EIGRP does this automatically by setting the AD, the external routes, to 170, right? But you're going to learn about other routes, which is probably going to be lower than 170. So You know, you want to make your redistributed routes a little higher if need be, or lower, whatever the case may be. It just depends on the situation. Another solution to that is tagging routes. That's another reason why I really like the sequencing of this exam. As you can see, we're not going to be even going over all of these solutions because there's separate videos for these. For example, route tagging and filtering is in objective 3.15a, and explaining route maps, which is another solution to fixing suboptimal routes, is using route maps, which we'll be explaining. I may just be doing some configuring of route maps because, yes, we did cover some route maps before, but for the CCNP, we only need to explain route maps. We're going to go further in depth with route maps because that was obviously all over the exam so far. Let's go ahead and spin up GNS3 and just do a little example of suboptimal routing and try to fix that problem. Okay, take a look at this topology here. We got router 1 and router 3. That is router 1 right here and router 2, are sitting in between two routing protocols. They are sitting in, router 1 is sitting in the OSPF domain as well as the RIP domain. Router 2 is doing the same thing, right? So they are our redistribution points. Pop quiz. Are these ABRs or ASBRs? That's y'all pop quiz for today. If you know the answer to that, put it in the comments below. Router 3 is obviously sitting in the OSPF domain. Router 4 is sitting in the RIP domain. Let's say, for example, well, we got tasks here at the bottom. We could do that. So let's say, before we do that, we need router 1 to send traffic to router 4, right? Obviously, if we need to send traffic, just by looking at this, you can see the best way to get to router 4 is from here to there, right? Well, you know what? We've configured this so that way it does not do that. It takes a suboptimal route for the purpose of this objective for the topic of the day. Task number 1: perform a trace route to 192.168.1.34. Where's that? It's located right here, right? 192.168.1.34. This is the 32/27 network. That's the 34. So we're going to perform a trace route from here to there, right? Here to there. Let's go ahead and do that. So let's go ahead and console in router 1. We're going to perform a trace route to 192.168.1.34. It look like it's wigging out over here. So we did a trace route. Obviously, we took more than one hop. So this is obviously a suboptimal route. Somebody done paid, oh, let's go this way because it's cheaper to go down this road when you could have just went that way. Duh. So from here, we went, our hops, it took 3, that should have been one hop, right? It should have just one hop from there. But no, we took the 10.003, which is located, 10.003, I believe is right here. That's our first hop. Then we went to the 10.00.34, which is, I believe, right over here. I should have labeled these. So we went from here to here. We went from here to there. That's the second hop. And then we went to 1.34 and made it to there. That's obviously a suboptimal route. We could have just went that way, right? Let's view router 1's task 2. View router 1's routing table. Let's go ahead and do that. Let's see why he did that, right? So we do a show IP route. You can see he learned. Here's the problem, right? Instead of like the 10, we was trying to get to the 1.34 network, right? But he said, oh, to get to the 1.34 network, which is in this network, right? /32. To get to this network right here, take this external route because the AD is 110, right? Well, where was that? Via 10.003, which is there, I believe. Yeah, 10.003, I believe, is there. We should go in there and console and make sure. But yeah, I'm pretty sure that that's 10.003. That's obviously not the best way to get there, but our AD said it was, right? Let's look at our administrative distance again. It said that our administrative distance was 110. So that's the reason why he took that instead of going that way. You would think, okay, this is a connected route, right? Connected routes, if you look at administrative distance, I believe it's 1 or 0. I believe it's 0 for a connected route, but no, he got a redistributed external route, right? So he don't have no connected routes for some reason. He learned about he does have a connected route, which is 1.0 network, which is here, right? But he's gonna take this connected. I mean, he's going to take this external route, which he believes is better. So he takes the longer way, obviously. So how do we fix that? Let's go back to our solutions and take a look. We said we can change the administrative distance of redistributed routes, right? That's what we're going to do. We're going to do that. We're going to manually change the AD, or administrative distance, using the distance command. EIGRP does this automatically, but no, this is not an EIGRP route. This was an OSPF route, so it wasn't done automatically. So let's go ahead and fix that problem. Real quick solution, y'all. Back to router 1, and we're going to say, where did he learn this from, right? He learned this from router, this guy. Actually, it came from him. He distributed to him, and that's how he learned it. So we're going to say, to get to this network, or any kind of routes that we learn externally, we're gonna modify that to a higher administrative distance. That way we don't have this problem. So we're going to configure terminal. Let's go into, this was an external OSPF route. So we need to fix our OSPF routes. Router, what was the process? First of all, do show IP protocol, I believe it's OSPF 1. So yeah, this is OSPF 1, right? Let's fix that. So we're gonna router OSPF 1. We're gonna change it with a distance command. We're gonna say distance, and we're gonna say OSPF. This is one way you can do it. We're gonna say any OSPF routes that you learn, set the distance. Actually, we're gonna say, I'll show y'all real quick. Let's do external routes. Any distance of external routes that you learn external, set the AD to, we need to set it to something that's higher. We're gonna say, yeah, to take this route, it's about $5,000 to get there. That's what we essentially doing. So instead of the 110, because we know external, I mean, we know that OSPF routes that we're learning, the AD is 110. So we need to set something higher than that. Let's say 195. After that, you can change inter and intra area routes. Say that 5 times, but we just gonna leave it real simple and do that. So now we do a show IP route. We are gonna see that, we changed our administrative distance to 195. So theoretically, he should take the directly connected route now, right? Because this was too high. So let's go ahead and do a trace route to that location again. Exit. I could have just controlled Z out of that. Learn them shortcuts, y'all. Let's do, trace route to 192.168.1.34. And you can see he took a direct route this time. It took only one hop to get there, 1.4, which is right here. So to get to 134, he just said take 1.4. That's directly connected to you. Let's change it. Let's get rid of that and try one more way to fix that problem. Configure terminal. We're gonna go right back into that OSPF process, number 1, and do let's get rid of that distance command, control A, no. And let's make sure do show IP route. And you see we changed it back to 110, right? Let's say for a specific neighbor we want to change their administrative distances. So we're gonna go right back into that process, router OSPF 1, and let's say distance, right? And instead of saying OSPF routes, we're just gonna change the administrative distance automatically. Let's say 145, right? And then say this is the source address. We're gonna say, you could actually just leave it as is, I believe, but let's give it a source address that we're going to learn these routes from. Let's say we're going to learn them from that right there. 1.33, right? So 192.168.1.33. You could change wildcard bits. Let's do it exactly that address. Quad 0. You could also do ACLs, but we're just going to leave that as is, keep it simple. Like I said, you can get further into this. You can get really creative as far as modifying the administrative distance and fine-tuning suboptimal routing behavior that may occur in your network. But like I said, there's just so many ways to fix this problem. We can sit here all day. We can make this a 2-hour-long video on how to fix these problems. But there's just so many variables and so many suboptimal routes that you can have on your network. We can't really explain them all or discover them all. We're just doing a simple one right here. So we're just gonna say we're gonna modify the distance of routes that we learned from that router to 145. And if we do a show IP route, you see we learned about this network and saying anything we learned from this network is a 145. So now I should have done another trace route to see that it took a longer hop. Let's get rid of that real quick just to see if that worked. We're going to get rid of this. And we're going to do a trace route to that location again. Trace route 192.168.1.34. You see it took 3 hops that time, right? That's a suboptimal route. Let's put back that distance command and do a trace route to that location again one more time. You see it took only 1 hop that time. That's just one way to fix it. Actually, 2 ways kind of we fixed it. Again, there are multiple ways you can fine-tune your network when your network is taking suboptimal routes to get to its destination. Again, route maps, route tagging and filtering, which we're going to cover in the next couple videos. We did the distance command. That's how we modified it. Or that's how we fixed the problem on that specific network. You could also route filtering. We've done route filtering. Go back in the CCNP playlist. That's one way to manipulate your routes so that way it's not taking a suboptimal route. And I believe we've done that a couple times. So if you like this video, please share this video on your social networks. If you really like my teaching style, share this on your Twitter, share this on your Facebook. Anybody that's learning about networking, let them know that I try to make this stuff fun. I am not your typical boring instructor. I'm not instructing, but I'm just learning. There goes my contact information right there. Please comment, like, subscribe to the network.